Hello curious people, today I will be providing proofs of the more used logarithm rules. I will be proving the product rule, the quotient rule, the power rule, and the change of base rule, and I will leave some example questions in the description for you to look at if interested. Let's start with the product rule. The product rule states that the log of a product is equal to the sum of the logs of its factors. Let log base a of x equal m, from this it follows that a to the power of m must equal x, let's call this result 1. Also, suppose we let the log base a of y equal n, from this, it must follow that a to the power of n must equal y. And let's call this result 2. Therefore, if we multiply x by y, x times y must equal a to the power of m plus n.
If we take the logs of both sides in base a, then by definition the log of xy in base a must be equal to m plus n. And if that's the case, we can see from results 1 and 2 that this must be equal to the log of x in base a plus the log of y in base a. Therefore, the log of x times y in base a is equal to the log of x in base a plus the log of y in base a. And that's the first proof complete. The quotient rule states that the logarithm of a quotient is equal to a difference of logarithms. Now the quotient rule is very much the same as what we previously did. Therefore we can use the same results. X divided by y is the same as a to the m over a to the n, which simplifies to a to the m minus n. Therefore, the log of x over y is equal to m minus n. And using the same results as last time, we get the log of x over y in base a is equal to the log of x in base a, minus the log of y in base a. Now, we prove the power rule. For the proof of the power rule, we write the log of x to the power of n in base a. X to the power of n is going to be repeatedly multiplying x by itself, n amount of times, and can be written as such. We already proved the multiplication rule, so, we can see that if we multiply any of these values together, it's the same as taking the log of them individually in base a and adding them together. So it's the log of x1 in base a plus the log of x2 in base a, and that will carry on all the way up to the final value, which is the log of xn in base a. And every single one of these logs has the exact same value, and if we repeat this addition n times, it becomes n multiplied by the log of x in base a. And that proves the power rule. And finally the change of base rule. The change of base rule converts a logarithm in a given base to a logarithm in a new base.
It tells us that if I wanted to figure out the logarithm of x in base a, I can figure it out by taking logarithms with a
different base. To make it more clear, if we want to figure out the logarithm of 25 in base 3, we can rewrite it as equal to the log of 25 in base 10 divided by the log of 3 in base 10. Which tells us that we can really take the log of anything in whatever base we like, because it can be represented as another log. Let's start with the proof.
Let the logarithm of x in base a equal y, and can also be expressed as a to the y power is equal to x. Now we can introduce log base b by taking the log of both sides in base b. We know from the previous rule that we can multiply the exponent by the same logarithm without the exponent. Isolating y gets us y equal to log of x in base b divided by log of a in base b. Plugging in the known value of y shows us that we are able to interpret logarithms in different ways. These are the proofs for the more common logarithm rules. Thank you for watching. I hope you learned something, and check the description for practice questions.